Hi, welcome to the redo, or this would be the version 4.0 of the fifth rule of acquisition. Now, in the past, this had it was called the Truth Conundrum. That's its short title. And this new numbering scheme, and we'll explain it at the end. So 5.0 is utility trumps truth. This is the best explanation I could find for this. The previous release of the fifth rule of acquisition had something like, if you want to find the truth, don't search for it, which was really obscure, and it really, I wanted to say things in there like, truth means nothing to science, but, you're going to see what I really mean by that. But if I put that down, people would automatically think that I am, supporting fraud, which I'm not. But if you see, so that's why it took me the longest time to come up with this best way of saying it. Like knowing what something is, knowing what something does, which is basically utility, is more valuable than knowing what it is. Okay? So that's what I was trying to say for the longest time, and I couldn't find these words. And so let's go on to, we're going to go right into electromagnetic theory with this, because that's what my website's mostly about, but I'm going to show this applies to just about everything in science. So people often tell me, I get people on there that, come up with all these proclamations of what a magnetic field is. Everything from, it's dried baby unicorn tears in a toroidal vortex of blah, 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 blah. Okay? Classical theorists tell me what a magnetic field is. They say it's composed of flux lines. And they put the iron filings on a magnet, and this is the pattern they get, and this is the pattern they've been using for 100 and some odd years. Fine. Then you have another guy, Ken Wheeler, and he's got this, I forgot the name of his tool that allows you to see patterns due to magnets. So he's got his own pattern based on what he sees, and that's fine. And if you want to go see that's his link right there. And he says things like a magnetic field is a reciprocating precessional hyperboloid which is divinely simplex. So what? Okay, we're going to go on. I'm not going to dwell on this. So let me show you. Just because I get a magnet, okay, and it does something, like here's a bottle of ferrofluid. Okay, I can put that over there and I get these things that look like little spine. It looks like one of those spices. I forget the name of the spice. Okay. And, well, does that mean a magnetic field looks like a dinosaur ridge? Like the dinosaurs had these spiny ridges on them? Well, I'm getting a different response from this material than the other two things I already showed. And then if I get a box of BBs over here, okay, I'm going to get a totally different definition of what a magnetic field is. Okay, and... well, this magnet, I'm not going to clean it off. It's going to take me too long to clean it off. And then I have a little bucket of water here. And if I put a magnet in a little thing of water, I pretty much don't see anything. Nothing's really happening here. So if I was to take this as my example of what a magnetic field is, I'd say there's no such thing as a magnetic field. Okay, so we have to be careful about trying to interpret what we see. Because you can get all different kinds of materials to behave all different ways in a magnetic field. Just because you get one pattern or another doesn't mean one's truer or more truer than the other. And then we get into the actions speak louder than words. Knowing what something does, what its utility is valuable. Knowing what something is worthless. So you can tell me that a magnetic field is a B-Bloplin-Borkendorfer in a semi-blah-blah-blah fluid, blah, 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 and I don't really care. That doesn't tell me what it does. It only tells me what it is, what you think it is. Okay, so I want to know what it does. I don't care what you think it is. This is the new numbering scheme. These are basically the same statement issued two different ways, and that's why you have 5.1a and 5.1b now. And let me give you an extreme example of what I'm talking about. There's everyone out there says they know the truth about the origin of the universe. Physicists have their Big Bang theory, which is their truth du jour. And then you have other people that believe in the creation theory. And then even Ethereal Mechanics proposes a theory too, mostly for fun. I don't claim it to be the truth. I just claim it looks a reasonable possibility. Okay, but none of these theories are likely to beat the truth. But suppose that one of these discoveries is discovered, or one of these theories is discovered to be true. Will this truth then affect how you put food on your table? No. Will this truth affect how you put money in your bank? No. This truth will not affect your life in any practical way. You're still going to do everything the way you did it yesterday. The only difference might be is there might be a whole new set of Discovery Channel shows which are going to take up your time because you're going to watch this new goofy theory that everybody believes is true. That might be the only way, but that's not a practical change to your life. That's just like an entertainment thing. Because there is no practical knowledge of knowing what something is, then we can encapsulate the knowledge of what something does in an abstraction. And let me give you examples of how abstractions help. For example, that's Ken Wheeler's model that he uses. You can go, that's his link there. So we have line abstractions, and here's a contour map of a topographical map. It allows us to see in 3 dimensionals using a 2-dimensional sheet of paper. It's a lie. You can't go out to your backyard and dig up the 200 meter above sea level line. It isn't there. But this is a good way to visualize 3 dimensions on a 2-dimensional sheet of paper. It's a lie, but it's very useful. We use field lines in classical theory. I can show where this doesn't work all the time, but in the instances where it does work, it's quite useful. And it helps us visualize. We have false color abstractions. You can't go to this part of India and see that the ground is actually painted green or purple or brown or pink. But this helps us visualize the arrangement of the different states. I think those are called states, I'm not sure. But it's a lie. It doesn't really exist. These colors aren't really there. But they help us. And then here's a false color abstraction of my graduate thesis work where I show the energy picked up by each part of the coil due to the emission of the rest of the coil, a compound coil. And it's a beautiful false color, and it allows you to visualize where the most energy is, and you can see where the white is. That's where the most energy is. The sun is just there in the background to make it cool. It doesn't have any effect on it. Then there's schematic representation. Circuits don't actually look like this, but it helps us visualize them for modeling. This is a lie. Circuits don't look like that. But we draw them like that because it's convenient for us to do so. Subway maps. There's a subway map of New York City. The subway routes aren't really lined out that way. This map helps list all the stops, and they're not necessarily proportional or to scale. And the different colors allow you to see which route is which when all the routes intertwine. So these are false representations. These are abstractions. These are essentially lies, but they help tell the truth. And they're easier. If you had a real map to scale, it would be quite useless. Okay, if you had the real representation, it would be very difficult to use. So sometimes the truth is difficult to use. And so we employ abstractions, which are lies, to help us tell the truth in an easier way. Now let's go to mathematical. Mathematical is an abstraction too. These are mathematical abstractions of what we think classical theory thinks a magnetic field is. And the B field of classical theory is pretty much a donut around a moving charge, according to the Biot-Savart model. And they show it like this. Is clip art. They show the field lines going around the loop. Okay, but if you really were able to show this more of a 3-dimensional donut shape, not really a disc shape to the field, and you put that around, you kind of get this pattern here. Now, don't get me wrong, it isn't confined to these lines. That's just a line of constant contour. It actually goes out like contour lines and gets thinner and thinner and thinner in magnitude as you go out. But it's essentially what we call toroidal shaped. Now, I have found in my research that this toroidal shape isn't sufficient to explain all the known things of magnetism. So in my world, in new electromagnetism, a magnetic field is a spherical phenomenon. And this is new electromagnetism, Coulomb's model, taken without change. These two here are derived from F equal QV cross B from this model here and this model, derived for non-relativistic case. And then new induction was found through experiment. You can watch the foundation series. That replaces Faraday's law completely. This is a spherical field effect. And then what I had to do in order to get, if this magnetic field is spherical, then of course these have to be, so I inferred the third term of new electromagnetism. And then later on I found there's actually an experiment out there that verifies this. That's well known, and it's interesting that that well-known experiment is not accounted for in classical theory. Because once you account for this, a magnetic field becomes a spherical. And so if you put a spherical magnetic field in a coil of wire, you're going to get the same toroidal shape of that coil of wire, because you basically, instead of having this case here, you basically have donuts that are threaded around a loop. Think of just having spheres threaded around the loop. You're going to get the same donut-shaped toroidal field, and that's why they nearly look alike. But when you consider charges that are free in space, that's where the spherical field makes itself known. And for induction experiments, that's also, you cannot get the right answers with only the toroidal field effect. For self-induction experiments, you have to use a spherical field. And so basically, you know, after humans know what everything does, and that's all I'm doing with this. I'm not trying to say, when I say that the field is spherical, I'm not saying what the field is, I'm just saying the shape has a spherical shape to it. I'm not saying what it's composed of or what it is or how the energy gets from point A to point B across space. New electromagnetism is not that. New electromagnetism is just trying to account for the charge-to-charge effects across the distance of space without trying to interpret what goes on between, except for the idea that, you know, a field should be spherical. The energy should radiate spherically from the source. That's the only, and I'm not saying what it is, I'm just saying it generally takes this shape. So in that case, when I use the word is, it is spherical. I'm not saying that that's an indicator of what it is, it's just that its shape is spherical. So we got to make sure we use the word is right here. And so that's all this is. This just accounts, and the purpose of the Railgun project is to validate these, because these were found, this one I'm very sure about, this one I've done the experiment 3 different times. About every 10 years I redo it just to double check myself. And then these were always derived or inferred, and so the purpose of the Railgun experiment is to kind of ferret out these and make sure there's nothing that I missed here. Because these are the magnetic, induction, and Coulomb field. So the key is we got to go around and find out what everything does. Don't worry about what it is. Find out what it does, what its shapes are, whatever properties you can determine from what we can discern about it. And then once we know what everything does, then it might be possible to discern what everything is. However, there will be no additional gain of utility from knowing that truth. The reason why is because you already know what everything does. All you're doing now is trying to say what it is. So you're not really going to add, you shouldn't add any new utility. If you do, that means there was something you didn't know about before you decide to discern what it is. And the truth is already out there. All we're doing is identifying it. That's not going to change anything. You know, rose by any other name smells just as sweet. Rule of Acquisition 5.3, abstract models of lies will provide utility long after the truth is known. We're still going to be using the abstract models because I guarantee you right now the abstract models are going to be simpler and help offer visualizations which aid our tiny brains. And certain simplifications are sufficient for certain applications. Let me give you an example. Like in navigation, they still teach that the sun rises in the east and settles in the west. Now we know that the sun doesn't move around the earth, but this visualization of it is easier to teach navigation through. And that's not my analogy. That's Carl Sagan's analogy. And in architecture, they still use the flat earth model as a good approximation for doing small structure design. No sense going through the trouble of calculating the curvature of the earth when you're going to just build an outhouse or a house or something small like that. And so we'll still be using simplifications and abstractions long after we know what the ultimate truth is. Okay, so these abstract models are essential, or these simplified or abstract models are not the truth. Essentially, they're lies. They're very useful and they're easier to use, and they're in many cases easier to teach. So don't worry about what something is. Don't waste time on that. Concern yourself with what it does. Abstract models that accurately mimic observed phenomena are exactly what we need in order to develop the fantastic machines which will expand our footprint. Now, the new rules of acquisition for Rule of Acquisition version 4, okay, the old way I used to have the short title, like this would be Rule of Acquisition 10, had a short title, had a key phrase, that I used to call it the Ferengi title, and then you'd have the supporting things, 10A, B, C. This is being changed now because I'm getting rid of this idea of the Ferengi title. I still have the short title is now just going to be the title, and it's just going to go by the number without a decimal point. The key phrase is going to be 10.0, and all the supporting phrases are going to be 10.1 through whatever. And then anything that are basically restatements of the same phrase are going to be just numbered by the same number with an A and B. Okay, and anything that was 10A is going to be 10.1. Anything that was 10B is going to be renumbered 10.2, etc., etc. And the Ferengi title is going to be just 10.0. Now, I'm going to release a complete punch list, of a complete document with all the rules of acquisition as soon as I'm done releasing. I'm not going to go back and revise the ones just for number changes. I'm only going to revise the ones that need to be revised because their material is out of date. And that includes all the first 5. This is one of the first of the 5. And then these guys over here. Then once that is done, we're going to, even when it gets close, I don't have them all down. I'm going to release, I think in a PDF format, all the rules of acquisition just in a list. So you can look at them, from one to the end. Thank you for your patience. The next 2 weeks, we're going to have more railgun releases. Got a lot of stuff to build to support the railgun stuff, and so got some more stuff done now, and we'll be showcasing the next 2 weeks. We'll have probably 2 railgun releases. Thank you.